the techniques that we're talking about are based on the multiplication principle. And the multiplication principle states that if each side of an equation is multiplied by the same number, then the resulting equation is true. Taking a simple example, the equation x equals y. What the multiplication principle says is that if I multiply the same number by x, for example, 3 times x, and I multiply the right side of the equation by that as well, 3y, the equation is still true. Again, to make this more intuitive, let's substitute in some numbers. Let x equal 5. Therefore, 5, if I substitute that in for x, 5 equals y. So if x equals y, then the equation is actually 5 equals 5 if I'm letting x equal 5. Okay, so I have 5 equals 5. And if I multiply both sides by the same thing, in this case 3, I get 3 times 5 equals 5 times 3, and that is 15. So if I have an equation, x equals y, and I multiply both sides by the same thing, the equation is still true. And looking at substituting numbers in, the original equation said 5 equals 5. If I multiply both sides by 3, the equation is still true, because 15 does equal 15. Division is slightly different. If each side of an equation is divided by the same non-zero number, then the resulting equation is true. Well, it's the same general principle that if I have an equation, x equals y, and I divide both sides by the same thing, the equation still holds up. The only caveat is that it has to be by a non-zero number. As you know from earlier math, you're not allowed to divide by 0. So other than that, it's the same idea as the multiplication principle. The strategy we're going to use today is to use either multiplication or division in order to isolate a variable. Illustrating this with just a simple example. 3x equals 15. In previous lessons, we learned about adding or subtracting in order to isolate the variable or to get the variable alone on one side of the equation. But here, that's not going to help me, because x is related to this number through multiplication. And remember, you need to do the opposite operation in order to isolate a variable. So as discussed with subtraction and addition, you need to do the opposite operation. In this case, that would be division. So what I'm going to do is divide by 3. X divided by 3 equals 15 divided by 3. Again, you absolutely have to do the same thing to both sides or the equation will no longer be true. Now, if I divide 3 by 3, that's going to be 1. So I have a coefficient of 1, and I've successfully isolated the variable. X equals 15 divided by 3, or 5. So this is an example of using the multiplication or division principle to isolate a variable. In this first example, we have y divided by 8 equals 24. Okay. When I look at this, in order to solve it, I need to get y by itself. And what I have now is that y is divided by 8. In order to eliminate the 8 from that side of the equation, I need to do the opposite operation, and the opposite of dividing by 8 would be to multiply by 8. Okay. 8 times y over 8 equals 24 times 8. Once again, I did the same thing to both sides of the equation. My 8's cancel out because 8 divided by 8 is 1. And that leaves me with y on the left side of the equation. And multiplying out 8 times 24 gives me 192. So I start out with y divided by 8 equals 24, and in order to isolate the y, I multiplied both sides of the equation by 8, which helped me solve the equation, which turns out to be y equals 192. This is an example that looks more complicated, but uses the same principles that we've been using. 3 2/3 times z equals 1/4. 3 2/3 is messy to work with because it's a mixed number. So first, change that to an improper fraction. In order to change it to an improper fraction, I'm going to say multiply 3 times 3, which gives me 9, and then add 2. So 3 times 3 plus 2, which will end up being 11, with the denominator of 3. So I have 11/3 z equals 1/4. Now when I look at this, I could go about it a couple ways. I could first multiply both sides by 3 to get rid of the 3. Then I could divide both sides by 11 to get rid of the 11. And that would require 2 steps and take longer. And besides being more work, the more steps that you do, the more chances you have to make an error. So it's always best to do things the shortest, most efficient way you can. The way to do this is to multiply by the reciprocal. Okay, so if you're going to multiply by the reciprocal, or the inverse of 11/3, you're going to multiply by 3/11. That's taking care of both the 11 and the 3 in one step. Doing the same thing on the right side of the equation. So I have 3/11 times 11/3 z equals 1/4 times 3/11, multiplied by the same thing on both sides of the equation. What this does is it allows the 3's to cancel out and the 11's to cancel out. That gives me z equals 1/4 times 3/11. So that gives me 3/44. Okay, and even though this looked messy at first, by changing this to an improper fraction, I was able to work with it, and then I multiplied by the reciprocal, and that canceled out the fraction that was multiplied by the coefficient of z, and I was able to isolate z and solve that z equals 44. Okay, in the third example, I have minus 13w equals 260. By now you know that we do the opposite. However, the difference here is that we have a negative sign. So we need to do the opposite operation once again. And that would be, since we're multiplying minus 13 times w, we need to divide. But we need to divide by the negative number, because it is a negative number. You divide by the same number that you're trying to eliminate. So I have a negative 13, and in order to isolate the W, I need to divide both sides by negative 13. Minus 13W divided by negative 13 equals 260 divided by negative 13. And I look at the left side of the equation, and what happens is my negative 13's cancel out, giving me a W. And on the right side of the equation, 260 divided by negative 13 is actually negative 20. Now, let's look back at what would have happened if I would have divided by a positive number. If I would have instead divided negative 13W by 13, I would have gotten a negative W. And if I want to solve for W, I don't want to end up with a negative W. It's possible to get rid of the negative sign later on, but then that's just an extra step. So if you need to use the multiplication or division principle, what you need to do is multiply or divide and retain the sign of the number. So if it's a negative, you divide by a negative. In this example, you'll see that we're back to sentences. So we're going to have to take that extra step of translating the sentence into an equation before we can solve. 3 2/3 times a number is equal to 5 3/4. What is that number? First, I'm going to assign the variable, and it says a number. So I do have a variable, and I'm going to call it x. Let x equal a number. I've assigned the variable. I've got to then write the equation, and then I'm going to solve the equation. Okay, so 3 2/3 times a number is equal to. It tells me right here that this left side of the sentence is equal to the right side of the sentence. Now that I found my equal sign, I'm going to start with the left side of the equation. 3 2/3 times a number. 3 2/3, and this is times. So I need to multiply times a number. And we said that the number is going to be represented by x. So 3 2/3 x is equals 5 3/4. Before I go on to solve an equation, I always go back and double check. 3 2/3 times a number, so times x, is equal to. So it equals 5 3/4. Now, as I did in the previous example, I need to change these into improper fractions to make them easier to work with using the multiplication principle. So 3 times 3 is 9, plus 2 is 11. So that is 11/3 x equals 5 times 4 is 20, plus 3, 23/4. Okay. I'm going to multiply by the inverse, or the reciprocal, which is 3/11. So if I have 3/11 times 11/3 x equals 23/4, I also need to multiply the right side by 3/11. And then what I get is the coefficient of x canceling out, because 3 divided by 3 is 1, 11 divided by 3 is 1, so that gives me x equals 23/4 times 3/11. And if you figure that out, it comes out to 69/44.